Okay, this will be a homework help on topic 5.7. I saw that a number of students were having some difficulties, so I thought I'd run a few more examples by you. Now, again, the flipped classroom lesson was quite extensive. We went over a lot of kinds of examples, and the classwork practice booklet, again, had many. And this is one we actually did, one very similar to it. So let's go over the protocol here. The area of a triangle is this. The height is 5 more than the base. So again, the picture of a triangle might be useful. This is the base of a triangle, and this is the height. So if we know the height is 5 more than the base, this will be the base times the height, which is going to be b plus 5. And that is going to equal the area of 375. But the original formula is 1/2 the base times the height. So one of the things I said I often do is just multiply both sides by 2. This is the 2's will then cancel out on this side, and this becomes then 750. And distributing that, we get b squared plus 5b. Now, putting this in standard form, b squared plus 5b, transposing this minus 750 equals 0. Now, the key to this is, and we said all of these can factor. And again, this form for figuring out what the factors might be, we know this is a b and a b. And then this is going to be 750. We know we can take a 5 out of there, and so on and so forth. You want to figure out the factors. In fact, we did one very much similar to this. Okay, let's go on here. Back to our regular screen. Again, one positive number is twice the other. Their product is this. So again, in setting up the equations, says one number would be x. The other number would be twice x, and then 5 more. And that's going to equal. So again, you distribute. Bring your term from the right over to the left by transposition, just change its sign. And once again, the strategy, when you go to factor this, there's no common factor, but you want to attack this. And if you recall the rule of 3's, if you add up your digits, this is a 6, and this is a 12. So this is divisible by 3. And this is a 9, so this is divisible by 3. And this is 15, and that's divisible by 3. So we have these products and this, and then fiddling with it. Again, I'm trying to give you a general pattern of strategy to solve this. All right, let's go on. Now, here's our Christmas tree. And it forms a right triangle. And we did one like this in our lesson here. Now, what we don't know is the height of the tree, so we'll call that x. Now, the guideline from the top of the tree to the post out here is 4 feet longer than the height. And the tree to the point of staking is 14 feet less than this. So this is going to be x minus 14. So in setting this up, it's going to be x squared using the Pythagorean Theorem, x minus 14 equals x plus 4, the quantity squared. And we did one like this. And then you're going to expand this, expand that, integrate everything over to the left, equal it to 0, and it does factor. Again, we did a model example like this already in our lessons. All right, let's go on. Again, now in this example, and another one that we did, very similar to this, one number, this is one number, and the other number is 40 more than this. And their product is a negative 400. So picking out which example it would be, that's pretty straightforward. But then you're going to distribute, move this over to the left by transposition, and then solve it by factoring. So we did one like this already also. All right, let's go on. Now, I found this one rather challenging. They're saying it's only medium difficulty, but let's go through it. So again, I would suggest you make a picture, a rectangle, and you know the diagonal of this rectangle is going to be 17. Now, the length of the rectangle is 9 meters more than triple the width. So we'll call the width x. So triple the width would be 3x, and 9 meters more plus 9. So there's our basic setup. So when we use the Pythagorean theorem, we're going to go x squared plus, now we have to put this in a parenthesis, 3x plus 9, the quantity squared, equals 17 squared. Now, 17 squared, I already know, is 289. And then I'm going to expand this for you, because this one's kind of tricky. So, x squared. Now, in expanding this binomial, we square the first term. That's 9x squared. Multiply these two together and get 27x. Double it for our middle term. That would be 54x. And then we square this term, which is a positive 81. Now I'm going to go to the white screen so we can work this out a little better here. Now we're going to combine like terms here. This is 10x squared plus 54x. Now when I transpose this over to this side, it becomes negative. And a positive 81 gives me a negative 208. And this now equals 0. Now I notice these are all even, so I'm going to divide everything by 2. Again, with smaller numbers, it's a tad easier to work. So this is going to be 5x squared plus 27x, and this is a negative 104, and that equals 0. Now we're asked to factor this. Well, we said that technique is 104, and that's even, so we can take a 2 out of it and get 52. Take a 2 out of there and get 26. Take a 2 out of there and get 13. And then 13 is prime. So again, we want to find factors. And we know this is going to be 5x, and this is going to be an x. Now, we want to get a 27 in the middle, but we know one of the signs is going to be negative. So 2 times 2 times 2 is 8. And then I have a 13 here. Now my outers need to be a positive here, so I'll make this a positive. And then this is a negative. Now when we equate each of these to 0, here this is x equals a negative 8. So we're going to reject that. We can't have a length. But here we're finally getting a fraction here. This is x equals, transpose that. That gives us a positive 13, and we divide by 5, which is 2.6. So this is one of the first times we've ended up with like a little decimal fraction here. And 2.6 happens to be the width. And one of the reasons I did this is when I worked this out this morning, I saw, wow, we're using fractions here, decimal fractions. And then if we add 9, we got to go 3 times that, and then add 9 to it, we get our other answer. So let's go back to the whiteboard, from the whiteboard, I should say. And it's, the length then is 16.8 on this example. Now I did this twice because I wondered, would we end up with a decimal? That gave me a caution because we hadn't had any that ended with a decimal like this. But it happens to turn out to be the correct answers here. Now again, we're showing a way to get this done. Now I want to show you one more thing here. Now another free math program that may help in things like this is a program Mathway. Now we did use Desmos, which could also be used, but I just thought I'd give you this as sort of an example. Now this works in a similar way here. If you go up to the upper left corner, and I've typed in the equation, and I have 5x squared equals 27x minus 104 equals 0, and then I entered and if we look, this is a parabola that you'll be seeing here, and you're getting to see some of the lines here. These are the x-intercepts. Now, one of our answers for that was a -8 that we rejected. That's this one. Let me get here. That's this one right here. There's your -8. We rejected that one. And then right over here, and it's kind of hard to see what it is, but that happens to be 2.6. So again, you've worked it out through your calculations, and there is proof that that equation does have that solution, although from this you're not able to pick it out here. And I just thought I'd pass that along as a kind of a helper. Now, I haven't used this for a while. I've made the graph a little bigger, and we can see the 2.6. Now that I've gotten into 5 things, it goes right through. This is 2.6, 2.7, 2.8, 2.9, 3. So there it is on 2.6. Okay, well, again, if you had a graphing calculator, that would help a lot to help support how to find this. And that's our help.